Welcome to NextEd, the tech education initiative by Nexuspaces, where we decode the core of electronics and embedded systems for the future tech leaders like you. In today's session, we explore one of the most critical topics in embedded systems, serial communication. Whether you're working with sensors, microcontrollers, or smart displays, your components need to talk to each other, and they do that through protocols like UART, I2C, and SPI. Let's break them down one by one, understand how each works, compare them, and help you decide when to use what. Let's start with the basics. Serial communication is a way of transmitting data between devices, one bit at a time, over a single wire or a pair of wires. This is different from parallel communication, where multiple bits are sent at once, across multiple wires, which takes more space and complexity. Serial communication is used almost everywhere in embedded systems because it's simpler, uses fewer wires, and works efficiently over longer distances. There are many types of serial communication protocols, but the three most important and widely used ones are UART, Universal Asynchronous Receiver Transmitter; I2C, Interintegrated Circuit; SPI, Serial Peripheral Interface. Each of these has its own advantages, limitations, and ideal use cases. Let's explore them in detail. First, let's understand UART, or Universal Asynchronous Receiver Transmitter. It's one of the simplest serial communication protocols and is commonly used for point-to-point communication between two devices. UART requires only two main lines: TX, which stands for transmit; RX, which stands for receive. It is called asynchronous because there is no shared clock line between the sender and receiver. Instead, both devices must agree on a common baud rate, which is the speed of transmission, like 9,600 or 115,200 bits per second. Now let's look at how UART sends data. Each piece of data is framed with a start bit, followed by 8 data bits, an optional parity bit for error checking, and 1 or 2 stop bits. This framing allows the receiver to recognize the beginning and end of each byte. Advantages of UART. It's easy to implement and widely supported in microcontrollers. Only 2 wires are required. Great for simple communication, especially for debugging. Limitations. UART can only be used to connect 2 devices, one transmitter and one receiver. It is not suitable for multi-device communication. Also, both devices must use the same baud rate. Common applications. Communicating with Bluetooth modules like HC05. Connecting GPS modules. Sending debug messages to the serial monitor in Arduino or ESP32-inch. Now let's move on to I2C, or Interintegrated Circuit, sometimes pronounced as I2C. I2C is a 2-wire, synchronous, multi-device communication protocol. The 2 wires used are SDA, Serial Data Line; SCL, Serial Clock Line. Unlike UART, I2C supports multiple devices on the same bus. This is possible because each device has a unique 7-bit or 10-bit address. Only the device whose address matches the master's request will respond. The master device initiates communication by sending a start condition, followed by the address of the slave and a read/write bit. The clock line, SCL, is also controlled by the master, ensuring that the data is synchronized between both ends. Data is transferred in bytes, and each byte is followed by an ACK bit, which is an acknowledgement from the receiver confirming it got the data. Advantages of I2C. It allows communication with multiple devices using only 2 wires. It's ideal for short-distance communication on PCBs. You can connect dozens of sensors and peripherals with just 2 pins. Limitations. It is slower than SPI, with standard speeds of 100 kHz or 400 kHz. As the number of devices increases, so does the complexity of addressing. It's not great for long-distance communication due to signal degradation. Common applications. Reading data from temperature and humidity sensors. Communicating with real-time clocks. Driving small OLED displays. Interfacing with modules like MPU 6050, BME280, and DS1307 inch. Now it's time to look at the fastest and most efficient Serial Communication Protocol, SPI, or Serial Peripheral Interface. SPI is a synchronous protocol, meaning it uses a shared clock to synchronize data. It requires 4 wires. MOSI, master out, slave in. MISO, master in, slave out. SCLK, serial clock. SS or CS, slave select or chip select. SPI allows full duplex communication, meaning data can be sent and received simultaneously. Each slave device is selected using a separate chip select line, which the master pulls LOW to activate that particular slave. Unlike I2C, SPI doesn't need addressing inside the data, each slave gets its own wire. Advantages of SPI. It's very fast, capable of speeds in the megahertz range. Full duplex makes it suitable for high-speed data applications. The protocol is simple and efficient for short-distance communication. Limitations. Requires more wires, especially if you have multiple slaves. No built-in addressing means you need a CS line for each slave. Not suitable for complex multi-device networks. Common applications. Interfacing with TFT and LCD displays. Reading and writing to SD cards. Using digital sensors and ADCs. Communication with high-speed DACs or memory chips. Let's now summarize the key differences between UART, I2C, and SPI with a simple comparison table. 1. Number of wires. UART uses just 2 wires, one for transmitting and one for receiving. I2C also uses 2 wires, a data line and a clock line. SPI needs 4 wires, for data in, data out, clock, and chip select. 2. Speed. UART offers moderate speed, suitable for many general-purpose applications. I2C is slower, usually capped at 100 kilobits or 400 kilobits per second. SPI is the fastest among the 3, reaching several megabits per second. 3. Communication type. UART supports full duplex, meaning simultaneous send and receive. I2C is half duplex, data travels one way at a time. SPI also supports full duplex communication. 4. Device support. UART is a one-to-one protocol, only 2 devices can communicate. I2C allows many devices to share the same bus using unique addresses. SPI supports multiple slaves, but each needs a dedicated chip select line. 5. Complexity. UART is very simple to implement. I2C has medium complexity due to addressing and acknowledgement. SPI is also moderately complex, especially with many devices. 6. Use cases. UART is commonly used for debugging, Bluetooth modules, and GPS. I2C is preferred for sensors, real-time clocks, and EEPROMs. SPI is chosen for displays, SD cards, and high-speed peripherals. Each protocol serves a different purpose, and your choice depends on your specific application, whether you prioritize simplicity, speed, or multi-device support. And that's a wrap on today's lesson from NextTED, powered by NexusSpaces. You now have a clear understanding of UART, I2C, and SPI, the 3 pillars of serial communication in embedded systems. Don't forget to like, subscribe, and hit the bell icon so you never miss an update from our IoT and embedded world. Drop a comment and let us know which protocol you use most often, or which one you'd like to explore next. Thanks for watching, and we'll see you in the next tech tutorial.